There's a place on this earth where governments send their best scientists, swear them to silence, and then tell the rest of the world almost nothing. A place where the rules of nature seem to bend, where the ground beneath the ice has not seen sunlight in 15 million years, and where what researchers have discovered in recent expeditions is quietly reshaping everything humanity thought it understood about life, extinction, and the future of civilization. The scientists who go there sign agreements. They speak carefully. They choose their words. And every single time someone asks them what really sits beneath that frozen surface, what they actually found, you will notice a pause, a brief, almost invisible hesitation. And in that hesitation, if you pay close attention, is the entire story. Nobody talks about Antarctica the way they should. That is not an accident. That is a design. Every year, governments spend billions of dollars sending their most brilliant scientists to the coldest, most hostile, most remote corner of the planet, a continent roughly 1.5 times the size of the United States, where 98% of the surface is permanently buried under ice, where temperatures plunge to minus 98 degrees Celsius, where the wind does not stop, where the darkness lasts for months, and where getting out in an emergency is nearly impossible. They send these scientists, they collect the data, and then they release carefully packaged summaries that say things like important climate research and polar ice monitoring and subglacial hydrology studies. And the world moves on. Nobody asks the next question. Nobody asks what is actually down there. But here is where it starts to get interesting. In 2022, a research team from the University of Gothenburg lowered an autonomous underwater drone named RAN beneath the ice shelf of West Antarctica. They were operating in the drift ice regions, and what they mapped in that hidden cavity beneath the Dotson ice shelf revealed unexpected teardrop-shaped formations that point to complex hydraulic activity influenced by the Coriolis effect, structures that challenged every previous assumption scientists held about how glaciers melt. When RAN returned for the second mission in 2024, something happened that was barely reported anywhere in mainstream media. The drone disappeared. On the return visit in 2024, RAN vanished without a trace under the ice. A machine worth millions of dollars, packed with the most advanced navigational and mapping technology available to modern science, simply ceased to exist beneath the ice of Antarctica. The official explanation was technical failure. But ask any glaciologist off the record what they think sits in those subglacial cavities, and the conversation changes very quickly. Think about what that means for a moment. An autonomous vehicle that can navigate the open ocean disappeared inside the cavity of a glacier. And the headline that came out of it focused on the teardrop-shaped structures, not on the loss of the machine that found them, not on what RAN might have encountered in those final 400 meters of unmapped tunnel beneath the frozen surface. The data it collected before it vanished was described as providing crucial insights. But crucial insights into what? Into mechanisms driving glacier melt? Yes. But also into something far more unsettling. The discovery that what sits beneath Antarctica's ice is not what anyone publicly anticipated. And this is where everything starts to change. For decades, the accepted scientific picture of Antarctica was elegant in its simplicity, a frozen continent, a vast sheet of ice. Cold, dead, geologically stable, scientifically important, but ultimately not hiding anything that would fundamentally alter our understanding of the planet. That picture is now completely, irreversibly destroyed. What actually exists beneath that ice is a world, a living, dynamic, hydraulically active, biologically populated world that has been sealed from the surface for millions of years. And the scientists who have spent careers studying it are only now beginning to grasp what that means, not just for climate science, but for the entire history of life on Earth. Let us start with the lakes. Beneath Antarctica's ice, scientists have discovered hundreds of subglacial lakes, bodies of liquid water sitting under 3 kilometers of ice, first uncovered in 1970 using radar systems. Read that again. Liquid water, under 3 kilometers of frozen ice. In a continent where the surface temperature is cold enough to freeze human tissue in seconds, there are lakes down there that have remained liquid for millions of years. Geothermal heat from the Earth's core keeps them in a liquid state. The planet's own internal fire is warming the water from below, even as the sky above freezes everything for as far as the eye can see. But here is where it gets worse, or more precisely, where it gets stranger. Lake Vostok, one of the largest subglacial lakes on Earth, measures approximately 160 miles long and 30 miles wide. Scientists believe the lake has been sealed off from the surface for at least 15 million years, creating an environment isolated from the rest of the planet. 15 million years. To put that in human terms, the last common ancestor of humans and chimpanzees lived roughly 5 to 7 million years ago. Lake Vostok has been sealed, cut off, silent, and dark for longer than the entire evolutionary history of the human lineage. Whatever is alive in that water has not interacted with the surface world in a time frame that makes human civilization look like an afternoon. And there is something alive in that water. That much is now confirmed. Researchers discovered that microbes called chemolithoautotrophs, bacteria that literally eat rocks, form the base of the ecosystem in these subglacial environments. They produce a basic carbon source for other organisms in the food web. Bacteria that eat rocks, life that requires no sunlight, life that requires no photosynthesis, life that has figured out how to survive using nothing but chemical energy drawn from the mineral composition of ancient stone, sealed beneath miles of ice, in complete and total darkness for 15 million years. And it is not just surviving. It has built a food web. There are organisms feeding off the organisms that eat rocks. There is an ecology down there, a hidden ecosystem operating on rules that science is still struggling to fully understand. But what was found in 2025 shattered even that picture. In August 2025, the Korea Polar Research Institute announced the discovery of entirely new microbial communities that have survived for thousands of years in complete isolation beneath the West Antarctic ice sheet. These were not variations of known life. These were not distant relatives of surface organisms that scientists could map onto existing biological trees. Genomic analysis revealed that most of the organisms belong to previously unknown species, genetically distinct from anything found in marine or surface environments. Unknown species, genetically distinct from anything else on Earth. Life that evolved in total isolation for so long that it became something new, something that has no parallel in the biological record of the planet's surface world. What most people are not seeing is the full weight of that sentence. Science has been searching for alien life for decades. Radio telescopes listen to the sky. Space probes scan the atmosphere of Mars. Billions of dollars pour into programs designed to detect the faintest signal of biology beyond Earth. And while that search continues, an international team of scientists quietly drilled through more than 1,000 meters of Antarctic ice and found life that is so genetically isolated, so fundamentally distinct from everything else alive on this planet, that it might as well have arrived from another world. It didn't, of course. It evolved here. But it evolved in conditions so extreme, so cut off, so utterly foreign to everything we call normal that it represents something genuinely unprecedented in the history of biology. According to informed sources within the polar research community, the full implications of these genomic findings are still being analyzed. The published data is significant enough. The unpublished data, the researchers describe in careful, qualified language, is extraordinary. Now here is where the stakes begin to climb. Because the thing about these subglacial ecosystems, these hidden lakes, these rock-eating microbe communities, these genetically alien organisms sealed beneath miles of ancient ice, is that they are not just scientifically interesting. They are fragile, catastrophically, irreversibly fragile, and something is threatening them right now, in real time, in ways that mainstream coverage is almost entirely failing to communicate. Below Antarctica's mile-thick ice lies a landscape of steep mountains and valleys, traversed by meandering rivers. Those rivers could play a decisive role in how the ice sheet responds to unprecedented warmth. Rivers beneath the ice. Rivers that flow, that carve, that carry water and heat and sediment through a landscape that has been buried since before the first primates walked the earth. And those rivers are now moving faster than they should. They are responding to something happening above them, something happening at the surface level that is sending warmth downward through the ice in ways that the model scientists use to project the future were never built to account for. Scientists currently use computer models to project future ice loss and sea level rise, but these models don't include the effects of subglacial river-driven melting. Let that land. The models that governments rely on to plan for climate futures. The models that inform infrastructure decisions and coastal development policies and international climate agreements do not account for the impact of rivers flowing beneath the ice. Researchers found that by 2100, subglacial rivers increased the ice loss from Totten Glacier alone by 30% over what standard models predicted. 30% more ice loss than expected from one glacier. And that is not included in the calculations that world leaders are using to discuss the future of coastal cities. But here is where it gets even heavier. Because Totten Glacier, while significant, is not the most dangerous piece of ice in Antarctica. That title belongs to Thwaites. Thwaites Glacier spans an area equal to the island of Great Britain or the U.S. state of Florida, and in places is almost 4,000 meters thick. The amount of ice flowing into the sea from Thwaites and its neighboring glaciers more than doubled from the 1990s to the 2010s, and the Amundsen Sea region now accounts for 8% of the current rate of global sea level rise. 8% from one region. In a world where a single meter of sea level rise would displace hundreds of millions of people. In a world where cities like Mumbai, Shanghai, New York, Dhaka, and Jakarta sit at elevations that make them catastrophically vulnerable to flooding events that would have been considered geological impossibilities just 50 years ago, Thwaites Glacier, widely known as the Doomsday Glacier, is changing more quickly than almost any other ice ocean system on the planet. Its future behavior remains one of the biggest unknowns in forecasts of global sea level rise. The biggest unknown. A glacier the size of a nation-state is behaving in ways that science cannot fully predict, and the models designed to forecast its future are missing entire variables, like the subglacial rivers underneath it, that may turn out to be the most important variables of all. In May 2026, new research published in peer-reviewed journals revealed something that almost nobody outside the glaciology community was discussing in public. Scientists uncovered a hidden Antarctic threat. Deep beneath floating ice shelves, long channels carved into the ice that could accelerate global sea level rise far faster than expected. Hidden channels, carved by water, inside the ice itself, moving heat from the warming ocean up into the body of glaciers that were previously believed to be more stable. This is not a distant theoretical risk. This is a mechanism that is currently active, currently accelerating, and currently absent from the calculations that the world is using to plan its future. The real story is not one of climate catastrophe and isolation. The real story is the gap, the enormous, widening gap between what the scientists in Antarctica actually know and what the public conversation about Antarctica actually contains. Now consider what was found in March 2026, reported by Science Daily but barely picked up by global news networks. Ancient river landscapes buried beneath the East Antarctic ice sheet have been uncovered by radar, revealing vast, flat surfaces formed over 80 million years ago before Antarctica froze. 80 million years ago, when Antarctica was warm, when the continent now encased in the largest single mass of ice on the planet was covered in forests, rivers, and life. Those rivers are still there, perfectly preserved under the ice, like a photograph of a world that no longer exists. They are flat and vast and ancient, and they tell a story that scientists are only beginning to understand about what Antarctica was before it became what it is today, and perhaps more importantly, what it may become again. Because here is something that the briefings leave out. Antarctica was not always frozen. It became frozen. It transitioned from a temperate, forested, river-crossed continent into the planet's ice warehouse over millions of years. And if that transition happened once in one direction, the laws of physics and planetary science say it can happen again in the other direction. The ice is not permanent. The permanence is an illusion built on geological timescales that human history is too short to perceive clearly. But the data coming out of Antarctica right now suggests that what took millions of years to build is potentially beginning to reverse, on a timescale measured in centuries. And the scientists know this. They have known it for years. The question that nobody in official channels is answering is exactly how fast. What the researchers who work in Antarctica understand, and what does not make it cleanly into press releases, is that the system beneath the ice is not passive. There is growing evidence that many of the Antarctic's subglacial lakes are connected by a network of channels. These channels control the flow of overlying ice streams, and liquid water at the base of ice sheets lubricates the passage of ice. The lakes associated with ice streams act as reservoirs for this lubrication process, filling and partly emptying, so the water in the lake is replaced every few years. This is the part that changes everything. The lakes are not just sitting there. They are filling and draining and refilling. They are moving water through channels that connect different parts of the continent. They are actively lubricating the movement of the ice above them, which means the stability of the entire West Antarctic ice sheet, the ice sheet whose collapse would raise global sea levels by meters, is partly dependent on the hydraulic behavior of a network of hidden lakes that science did not even know existed until the last few decades. And one of those lakes has now been found to contain life that has never been seen anywhere else on Earth. Think about what that means in operational terms. The organisms living in Mercer Subglacial Lake, the ones identified in August 2025 as genetically distinct from any known species, live in a water body that fills and drains on a cycle of a few years. They have evolved in conditions that shift. They are not static. They are adapted to a dynamic environment. And if the warming of the ocean above accelerates the rate at which those hydraulic systems move, if more heat means more meltwater means faster filling and draining of the subglacial lake networks, then the ecosystem those organisms inhabit begins to change faster than it has changed in the thousands of years over which their current genetic profile evolved. But here is where the story splits into two separate threads, and both of them matter. The first thread is the environmental one, the one about ice collapse and sea levels and coastal flooding and the billion people who live within a few meters of sea level around the world. The second thread is stranger, and in some ways more profound. It is the thread about what the discovery of genetically alien life in an isolated subglacial lake means for the search for life beyond Earth. The presence of unique life forms in an isolated environment like Lake Vostok has spurred interest in studying it as a potential model for life on other planets, such as Jupiter's moon Europa, where a similar subglacial environment may exist beneath its icy surface. Europa, Jupiter's fourth largest moon, a world covered in a global ocean of liquid water, sealed beneath a thick shell of ice, existing in total darkness, heated from below by the gravitational stresses of Jupiter's enormous mass. NASA has a mission currently in development specifically to explore that ocean. And the model for what might be alive in it, the template that scientists are using to understand what life could look like in a sealed, lightless, pressurized, geothermally heated underwater environment, is Lake Vostok. Antarctica is not just a climate problem. It is the laboratory for the most important question in the history of human scientific inquiry. Are we alone? And right now, the answer coming out of that laboratory is becoming more complicated. Because what the 2025 discovery from Mercer Subglacial Lake demonstrated is not simply that life exists in extreme conditions. That much was already established. What it demonstrated is that life, given sufficient isolation and sufficient time, diverges from everything it is related to so completely that it becomes effectively unrecognizable. Genomic analysis of 1,374 single-cell amplified genomes revealed that most organisms belong to previously unknown species, genetically distinct from anything found in marine or surface environments. 1,374 individual genomes analyzed, most of them unknown, in a lake 1 kilometer beneath the surface of Antarctica. This is not a footnote in a scientific journal. This is a fundamental expansion of the known boundaries of life on Earth, and it happened in the same year that Antarctic research budgets were being cut. According to informed sources in the polar science community, the National Science Foundation reduced support for Antarctic research during the 2025-2026 field season. This season has been marked by reduced support for Antarctic research by the National Science Foundation, including the cessation of operations of a key research vessel. At the exact moment that Antarctica is producing the most scientifically significant findings in a generation genetically unknown organisms, hidden hydraulic systems influencing ice stability, subglacial rivers accelerating glacier melt beyond what models predict the institutional support for the research is contracting. The funding to go back, to drill deeper, to map further, to analyze more genomes is becoming harder to secure. What most people are not seeing is the contradiction at the heart of that situation. Governments will spend trillions in the coming decades responding to the consequences of sea level rise, coastal flooding, climate displacement, and ecosystem collapse. The number being discussed in serious policy circles for infrastructure adaptation and climate migration over the next 50 years exceeds $20 trillion globally. And the research that would tell us exactly what is coming, the work happening in Antarctica right now, the mapping of subglacial rivers and hidden lake networks and glacier dynamics is fighting for funding measured in millions. This is not chaos. This is a failure of prioritization so profound that future generations will study it the way we now study the moments when early warning signs were ignored before other civilizational turning points. Meanwhile, beneath the ice, the discoveries keep coming. Pink granite boulders sitting atop Antarctica's Hudson Mountains have led scientists to a stunning discovery, a hidden granite mass buried beneath Pine Island Glacier, stretching nearly 100 kilometers wide and 7 kilometers thick. A granite mass the size of a small country, completely hidden beneath one of the most actively retreating glaciers in West Antarctica.